Today, we're going to walk through my latest n8n automation template. The workflow automatically grabs Microsoft Teams transcriptions and analyzes them. Once the analysis is complete, it emails you a summary, and the email contains a link where you can open up a web app. It's actually a fully interactive web app where you can draft follow-up emails using AI based on the meeting context and save them directly to your draft folder within Outlook, ready to send to participants of the meeting. The analysis is detailed and participant aware. It includes a full summary, strategic takeaways, decisions made during the meeting, and clear actions grouped by owner. You can also push out to third-party tools. So in this case, I'm using mem.ai, which is an AI-powered note-taking tool, and it allows you to chat with your meeting context and any other notes that you have in there. So you're never going to forget what was discussed. You always have a reference point that you can quickly refer back to in the future or search based on memory. So really good tool. Recommend you check it out. So after we walk through the templates, we're going to tackle a common challenge within n8n automation, and that is the fact that workflows only run per user. As you'll know, you need to sign into n8n and create credentials within the platform, which means that each workflow is tied to the credentials within the workflow. We're going to flip that on its head, and I'm going to show you how to transform a single user workflow into a multi-user workflow, something that can then be used across your entire organization. So to do that, we are going to deploy a solution that we've developed internally here at No Code Creative. It lets users securely authenticate using Microsoft Auth 2, and it takes care of token management behind the scenes. And this allows your automations to run on behalf of multiple users without the hassle and stress of having to manually worry about individual credentials or multiple workflows within n8n or whatever automation platform you're using. It's going to be a deep dive, but stick with me. You'll learn how to build enterprise-grade automations for real-world business needs. Both versions of the template are going to be available, so the single-user version and the multi-user version that we are going to create today. Head over to the n8n template marketplace for the single-user version. The multi-user version is available exclusively via my blog. Check it out in the description below, and the authentication platform is also available as well. Be sure to check out the blog for a full description. There'll be plenty of information in there in terms of how to set this up. We will be using an external database, Postgres in this case, which does require some self-hosting and setup. So the blog will contain all the information that you need on how to get that running. Now, a pro tip would be to use Supabase, as it exposes a connection string that allows you to connect to the underlying Postgres database. And in n8n, you can use a Postgres node to connect directly to Supabase. So if you're not comfortable deploying your own Postgres database, that is an alternative solution. But without further ado, let's dive in. So the first thing that you're going to need for this template to work is a Microsoft Azure app registration. So go to portal.azure.com, sign up for Microsoft Azure. It is completely free. There's no cost to creating an app registration. Once you've logged into Microsoft Azure, you should see an app registrations button. If you don't, you can search for it here. Simply come to new registration, give it a nice recognizable name, choose whether you want it to be applicable to a single tenant, so one organization, or multi-tenant, and click on register. You'll want to take note of your client ID, and you'll want to take note of your directory, your tenant ID as well. The next thing you're going to want to do is come down to authentication. n8n will provide you with a redirect URL. So this is where you enter your redirect URL. You need to make sure that access tokens and ID tokens are checked, and it will give you another opportunity here to select single or multi-tenants if necessary. Then you need to come down to API permissions, and you're going to want to add all of these permissions. Now, I will leave a list of these permissions on the blog post. To add each permission, all you need to do is click on Add Permissions, and then you can choose Microsoft Graph, and you can either choose Delegated or Application Permissions. So, for example, delegated permissions, the first one is calendars. You can see calendars.read. All you have to do is tick it and then click on Add Permissions. Same for application permission. All you do is switch to application permission, for example, call records, and there you go, just tick it and press Add. Similar for SharePoint, you would just look for SharePoint from this list, delegated and application permissions, and you would go through the exact same process. Once you've added your permissions, head over to certificates and secrets, and you want to create a new client secret. Give it a name, give it an expiration, and once you've done that, click on Add. It will give you the value, enter into n8n. You'll only get to view this once, and then it will disappear. So make sure you take a note of it. And that's how you set up an app registration. So once you've set up the app registration, you are good to go. Okay, so we'll start with an overview of the existing template. As you can see, there are 3 triggers on this template. There's a form trigger here, which isn't really needed, but if you did want to manually download a VTT file after a recording, this form would allow you to manually process that file for whatever reason. You may have historic meetings that you want to go and get the file for and put it through this process, and the form trigger will allow you to do it manually, effectively. So it looks for a VTT file, which after a recording you can download directly in Teams or from Microsoft Stream, and it just asks you for some inputs, and then we have a code node just to format those outputs so that it's correct for the rest of the workflow. But the primary focus of the workflow is to run on schedule. So we are using a schedule trigger, which runs every 5 minutes. And of course we have a manual trigger here as well for testing. Next we have a merge node, and that's just to unify the inputs. And then we have a get profile node. So this is just a HTTP request. We are doing a call to the Microsoft Graph endpoint to get the profile of the current user. Okay, so the way that we're doing this is it's basically, well, we're authenticated using OAuth 2 API credentials built into n8n, and I've connected that to my personal account. So it only works in the context of me right now. The goal later on is we're going to adapt this workflow to work with multiple users. So one workflow, multiple users, and we're going to use an application which I've just finished developing, which is available, which will allow workflows to work across multiple users. So we'll go into that in a bit more detail when we update the workflow. But for right now, we have attached this to a single credential, and this credential is connected to the Microsoft Azure app registration that we created earlier. So once we've got this set up, basically allows us to get the user that's tied to these credentials. And what we're looking for here is the ID of the user. So we're going to use that later on within the workflow. Now this is our starting point. Then we have an if node, which is checking to see if the data has been submitted by the form or not. So if it has been submitted by the form, it's essentially going to bypass the rest of the workflow and go straight into our meeting analysis over here, which we'll come back to in a bit. If it hasn't been submitted by the form, we are going to set a time range here. So essentially what we're going to do is we're going to get core records, but we're going to restrict the time frame in which we're returning those records for. So within this set time range node, we have an expression. An expression essentially gives us a date in the past, and that is derived by the minutes ago variable in this expression. So you can change this to suit your needs. 420 in minutes is about 7 hours, so we're always looking over a working day almost. So if you wanted to go further back in time, you can extend that as far as you like if you want to process old records. Okay. Once we've set the time, we're going to call another endpoint within the Microsoft Graph API. And as you can see, there's a filter expression here, which is making sure that we only get records that are greater than or equal to the time that we created in the previous node. Now, word on this one, the get core records endpoint is only available with application permissions. So there's when you create your Azure app registration, there's 2 different types of permission. We have delegated permission, which is based on the user that's signing in, or we have application permissions, which are based on the user, so they can look at everyone's records within your Microsoft tenant. The core records endpoint is only available for application permissions. So therefore, the credentials that we set up are slightly different. They're still OAuth 2 credentials, but we're using application permissions within the Microsoft Azure app registration. If you want to get core records across multiple tenants, you will have to have separate HTTP requests for each tenant, which I'm going to do. So we're going to update this to work across multiple tenants when we adapt the workflow. So I'll come back to that in a bit. But the template by default is set up to work with one tenant. Most people are probably only working with one tenant. Once we've got all of our previous core records, we are going to have a look and make sure that we only get the relevant ones. So we have a code node here, and we have a small description here of what this code node does. So as you can see, it processes a list of Microsoft Teams meeting core records and filters and sorts past meetings. So extracting all the core records from the input data, it filters out things that have not ended yet. Anything that has ended less than 5 minutes ago, it filters out because sometimes there's a lag between the transcription becoming available after the meeting ends. So this just gives us an opportunity for the system to catch up before we try to get the transcription. We're also filtering out meetings that were not organized by the user. And that is because we cannot get transcriptions that are not tied to the authenticated user. So we're filtering anything else that doesn't match the ID from the get profile node. We're taking the ID there and we're doing some filtering within the code. Yep, so then we're going to sort the meetings by end time. It's going to return a nice clean output for us to work with. So in this case, it's found 2 meetings, as you can see, and it's outputs all the details that we need to process them. In order to identify if the meeting could potentially have a transcript, I should say that just because there's a core record doesn't necessarily mean it has a transcript. So we need to do some filtering to make sure that what we're going to process does have a transcript. And to do that, the first thing that I identified is that it needs to have an online meeting URL. So if it's an online meeting, it will have a join URL. So we're going to make sure that we have a join meeting URL. It's going to filter out anything that doesn't. Using that join URL, we're then going to use the online meetings endpoint to grab more details about that meeting. So as you see, we're kind of filtering meetings that match that join URL, and then we're returning the information available from the Microsoft Graph to endpoint about that meeting. Now, of course, there could be multiple meetings at this point, so we're going to split them out. Then we're going to just do a check for duplicates. So this is a really good node within the n8n. If you haven't used it, well worth using. It's very handy. And this is just really a safety. We don't want to process multiple records with the same meeting ID. So we're going to remove any duplicates before continuing. You can remove items that have been previously processed in previous executions, but that is not what we want for this workflow. So the next thing that we're going to do is grab the ID of the call. So we'll have a look here from our filter node. There is an ID field. So I'm just going to grab that ID and we're going to append it to the final object. So we have a call ID here. So now we have got all the details of the meeting and the call ID as well. The call ID is coming from the core records node. The call ID wasn't included in the get meeting details node. So essentially what we're doing is we're appending the call ID to the meeting object. Then we have all the data that we need in one place. The next thing that we are doing here is we're saving all of the data to a Postgres database. The reason for doing this is twofold, really. So the reason we're saving to Postgres is twofold, really. Essentially, we have a web application that is going to be served via email and people can access anytime. So we need to have all the information saved somewhere where it can be accessed at any time. So we have a Postgres database where we're saving everything. And this also allows us to have some logic in regards to checking if something has been processed or not. Now, you would have seen from the schedule trigger earlier that this workflow runs every 5 minutes, and sometimes there is a delay with transcriptions becoming available. So essentially we have some retry logic in here. It runs every 5 minutes. If it doesn't find a transcription in the third run, then it's going to stop processing it any further, and it's going to assume that there's no transcription available. And this is because the core records only become available when a call finishes, or we're filtering out to make sure that we only get records of a finished call. So if there's not a transcription available after 15 minutes after the call has finished, then we're going to assume that there's no transcription for that meeting, and therefore we're going to stop processing it any further. Because if you remember, we have a 7-hour window, which we set back over here with our time range. So we don't want to keep trying to process the same object for that 7 hours. We're just going to try 3 times and then stop. And I will include in the template some documentation which will allow you to actually set up this SQL statement that will allow you to create the database. But if we have a look at the node, you can see that we are using execute query and we are inserting all this information into the database. And we have on conflict to make sure things are updated. And then we have an attempt count down here, which is going to increment by 1 every time. And we're also setting the time of processing as well. So I'm not going to go over the SQL statement right now, but there will be some more detailed notes and statements that you can actually create this with your own Postgres database. So because we are using a SQL query to check if records have been processed, there will be occasions where it just doesn't return anything because there's nothing left to process. And if that's the case, we want to filter out. So if there's no items to process, then stop. So the output from the Postgres node will have a success object. And if that success object exists, we're going to stop at this point. And then we're using a merge node here. So after we make sure that there's an item to process, what we actually want to do is go and grab the item, and then we want to match that item against what's coming out of the Postgres node. So if the Postgres node finds something that needs to be processed, it's going to output it here, and it's going to output it here as well. And obviously it's then going to keep it. And then we're going to go into the code node, and all we're doing here is just grabbing the data that has came out of the combine IDs node, okay, which is what I showed you earlier, where we are grabbing all of the data for the meeting and appending the call ID at the end. Okay, so that's just grabbing all of that data, and the same data is going to be coming out, or a slightly stripped back version of that data is going to be returned from the Postgres node. The important thing is that there's a call ID coming out of the Postgres node, and coming out of this code node, because we're pulling from the combine IDs node, we also have the call ID down here. Okay, this is then going to allow us to keep matches, right? So the Postgres node, if it's already processed the item, it's not going to output it. Okay, so this then is essentially some filtering, right? If there's a match between what comes out of the Postgres node and what's available over here before we've processed it, then it's going to keep those matches by combining them, matching fields based on the call ID. And that then gives us the items that we still need to process. So by this point, we have verified that it is an online meeting. It meets our conditions for processing, keeping the matches. This then allows us to check if there are transcriptions attached to those meetings. We are doing another call to the online meetings endpoint within Microsoft Graph, and we're using the meeting ID and we are hitting the transcripts endpoint, and we're doing this based on the user, because we are using OAuth 2 API or credentials for the user that authenticated within n8n. So again, we're going to change this later so that it will work for multiple users. We have changed the settings here to continue finds an error. And the reason that we're doing that is because sometimes transcription data may not be available via the transcription endpoint. So for example, if you use a third-party tool to schedule meetings, Calendly, cal.com, whatever it may be, the transcription is not available via this endpoint because it saves it in a different location. Okay, so we've got two paths that come out of here. In this case, the meeting in question was scheduled by a third-party tool, so it hasn't found a transcription, and therefore it's given us an error. So we can look at the error output of the node, and if you come down to the error, it couldn't find the online meeting calendar ID for the meeting that we are trying to find a transcription for. So what we're going to do, after some investigation, some quite deep investigation, I figured out that if we transcribe a meeting that was created by a third-party tool, transcription is still saved within the user's SharePoint folder. So what we can do is we can actually search to try and find the transcription that relates to that call that was created with the third-party tool. So that is what this HTTP request is doing. Okay, so we're using, again, Microsoft Graph. We are looking at the user's folders, actually within SharePoint. It's where they're saved, under the hood. What we're actually doing is we are searching with the subject of the meeting. And the subjects always have, when they are saved to this particular location, they always have the date and time at the end. So your results may vary a bit with this. If you have, for example, multiple meetings with the exact same subject on the same day, then it's going to return multiple meetings. So You may want to extend this to include a time parameter, but for me, I'm very unlikely to have multiple meetings with the exact same subject on the same day. In this case, let's search SharePoint, and it's found that there actually is a meeting that matches. And if you look at the dates here, you can see there's a date here at the end, and there's a timestamp here too, and it's got meetings transcription.mp4 at the end. So this is actually recorded and it's found, and this is actually hidden. You have to dig, if you go and search through OneDrive or you go and search through SharePoint, you're not going to find this. It's only available via the API and it's not documented. So you have to do quite a bit of digging to actually find this, but that's where it is. And here we can see actually there is a transcription available. So it's found a meeting that has been recorded. Now, because this can return multiple results, the data that we need is within an array. This is value array. So we're going to split out the items from that array. So we have our individual meeting items. And then what we're going to do is we're going to list those transcriptions. After some investigation, we found out exactly where they were saved, and we can use the ID of the recording, the drive ID, and the drive ID of the recording to then see if there's a transcription that relates to that recording. And in this case, there is. So here we have found a transcription that relates to that recording. There's a download URL that is output. Here we go, download URL. And we can see that we can go and grab that download URL, and the result is we get our transcription. If this is a meeting that has been scheduled via Outlook or scheduled via Teams, it doesn't need to go through this process. So we get rid of the search, and then all we do is make sure there is a call ID available. If there's a call ID available, we can go and check straight away and see if there is a transcription available, okay? And we're requesting that the transcription gets returned in a text or VTT. So once we've got our transcription, what we're doing is we have a merge node over here to unify the data. So in all three instances, whether it's coming from our form or whether it's coming from our schedule trigger, whether we have found the transcription through because it's been scheduled via Teams or Outlook, or if it's been scheduled via a third-party tool. So we've got three potential ways to find a transcription. So what we need to do is ensure that we unify all of the inputs so that we can then process them later on. We're just grabbing all the data from the previous nodes that we need and giving them all unified names, keys, so that we can use later. And then we're using our merge node. And then what we're going to do is we're going to loop over each of the transcriptions, and then we're going to process them with AI. So we have our loop, we have our meeting agent and meeting analysis agent here, and the meeting analysis agent, as you can see, it's got the name of the meeting organizer, the email, and the subject, and then it gives us our full transcription down here, ready for processing. We have a very comprehensive system prompt in here. I'll let you read over this in your own time, but we have a directive of what it needs to extract. We're giving it the output that we want. So there's an output structure that we specifically want so that it can be used later. So we're essentially getting two outputs from this AI agent. We are getting a very structured output of the meeting analysis, and we are also getting a draft email output, a summarization of the conversation. And we're asking the AI agent here to output its analysis in JSON. So within the OpenAI chat model down here, we're using 4.1 because it's very good at that. We've set the response format to JSON, and we have lowered the sampling temperature down to 0.3, and that is for consistency. What I'm actually doing is I'm setting the JSON using a set node here now. So there are multiple ways to get JSON from an AI agent within n8n. You could use a tool and use a structured output parser. However, I find it more reliable to quite simply prompt the agent to output the JSON that we need, and it's going to output it as a string over here. As you can see, we have our JSON object, and if we use a set node, it's going to take that string and we can set it to object, and then we actually get our structured output at the end. And I find this to be more reliable than the structured output parser. Personally, I prefer it, so that's what I use. Here we can see we have got all the information that we need to generate the static web page, which the user then clicks on after they receive the email to have a look at their meeting analysis. So once we've set our JSON, there's two things that are going to take place. We're going to send the user an email to say that the transcription is now available. So we're using a HTML node for this, which then gives us a nice email to send out. And I'm using an Outlook node to actually send that email. Now I need to change this again. This is set up to work with the authenticated user. We're using a credential. So I'm going to change this to work with multiple users and change it to a HTTP request. And then we are also generating our static web app down here, which I will show you separately because it doesn't look too great there. This is just an example of how the web app looks. You can see that we have our summarization, our strategic takeaways, decisions, context, and then we have action items for each user. You can collapse these if you like. We can copy these to clipboard if we want to put them elsewhere. We can add it to our knowledge base, and we can draft a follow-up email as well. And the follow-up email will then become available. It will just sit within your drafts folder within Outlook, effectively ready to go. And you can add more context if you like. You might want to tell it to pull out some specific information from the meeting summarization that you're liking that to highlight in that email. And this gives you the opportunity to do it rather than have to change it later. Okay, so we then save all of that information into Postgres so that we can serve the web app. A couple of things to note about the web app. Now, this is a static page that we're serving. So we are using content delivery networks here to actually be able to serve the web app using JavaScript. Because we can't use JavaScript here, but we can use a content delivery network to serve JavaScript just outside of n8n. So that's what we're doing here. This is what gives us the extra functionality. And as you can see, there's quite a lot of dynamic inputs that we need to grab from the structured output that's coming from our agent to create this. Okay, so the next part of this workflow relates to the web app and relates to these two buttons here. Now, you can customize this to suit your own needs. There's two webhooks. This webhook relates to the email. So when the user gets the email, there's a button. When they click this button, it calls this webhook. This webhook then grabs the meeting role from Postgres, and it uses the ID to get the correct role, which is generated back over here in the email template. It's going to grab the role from the database, and then we are responding with text, and we are responding with the HTML summary that the AI agent created, which allows us to render this web page. The second part is this webhook here, and this webhook specifically relates to these two buttons. So you can customize this to suit your needs. It's set up to take in a post request. It's going to take the ID so it gets the correct role that relates to the meeting. Then what I'm doing for my specific purposes is I am grabbing the HTML and using this HTML to markdown node. We're basically stripping out all of the HTML so that we just have markdown left. And that is because we're going to send it to AI, and we don't need to give the AI all the HTML. It's a waste of tokens. We don't need it. And then depending on which button is clicked, we have a switch. If we press the Add to Knowledge Base button, it's going to come down the note route, and therefore it's going to route up to here. You obviously could take these outputs and put them on a different platform. You don't have to use mem, but it's worth looking at. And all we're doing is responding to say it's complete. Other option is to draft our email, which, as I mentioned before, you can give it instructions to create that draft. It's going to send it off to our agent here and receive the sanitized data from that HTML to Markdown node, our instructions from the front end. It's also going to send in the participants that we have saved in our Postgres database. And then we have some prompting here, how we want that email to look. So do come in here and change that if you need. And again, we are specifying how we want that email to look in JSON down here. So once it's drafted the email, we are following the same process as previously, setting an object, and then we are using our Outlook node here to go ahead and save that draft, and it will then be available within Microsoft Outlook for you to review and send out to your contact. Again, I wanted to change this so that it can work for per user, which is coming in the next part. So that is an overview of the template. Hope you found it useful. Okay, so now we're going to take this template and we are going to change it so that it works with multiple users across multiple Microsoft tenants, and give it, really kind of upgrade it from that kind of personal workflow to something that can be used across organization. And to do that, we need to change the credentials that are being used, because as I mentioned previously, credentials are only tied to the user that authorizes with the credentials in n8n, which is no good for multi-user workflow, which we are going to turn this into. So the first thing that we need to do is we need to be able to actually get access tokens for multiple users. And to do that, I've developed an application which will allow us to do that. So it's an application which can be deployed on your own infrastructure. You can deploy it in Azure. Security is a concern. And because you're deploying it in Azure, you can restrict access to intranet, your own tenant, your own employees, your own staff, your own organization, whatever you want to call it. So I've deployed the application, and this is the application here. The application allows us to sign in with a Microsoft account, and the first person that signs in is granted administration permissions, and you'll be asked to accept the scopes from your Microsoft Azure app registration as you sign in. You can grant for the whole company, or you can grant a user. Obviously, the point of this is that other people in the organization can sign into this, and once they sign into it, that's really all they need to do. So I'm signed into an admin account here. As a standard user, you wouldn't see the users tab, and you would only see your own token status. Non-technical users can use this. All they have to do is sign in. They don't need to worry about anything else. So that's what you would do. You'd get your team, your departments, people in your organization to sign into this application, and this then takes care of all the token management. So as an admin, you can come in here and you can see what's connected. You can see the users that's connected. You can see which accounts have been connected, whether they're SharePoint or Graph. You can see tenants, tenant IDs, the current status of the tokens. We have a settings tab here which allows you to grant API keys and revoke API keys. And we have some API documentation which you can have a look over, determine what we need to do. And I'll go into this in a bit more detail. And we, as an admin again, we have a user tab here. Within the user tab, you can grant people admin permission, and you can grant or revoke API access. So if you don't want to give individual users API access, don't grant it. If you want other members of your development team to have access to all of the tokens within the system, you would give them administration access. If we look at the documentation here, you can see that this endpoint, the main endpoint, essentially returns either your own tokens if you're a standard user, regular user, or if you're an admin, you can access tokens for anyone that's signed in. Now, there's an endpoint which will call from n8n, which will get the tokens, and it's going to return the tokens in this format. The access tokens will be in a encrypted buffer array. So we have to decrypt those tokens within n8n, an extra level of security. And to do that, there's a code example within this application which you can copy and paste into n8n. So back over in n8n, I have created a sub workflow called get tokens. Yeah, so we're going to execute this from the main workflow. This is going to call our get tokens endpoint. I've already created the API key and saved it here. So we've saved it as a header auth, X API key, and then our API key here. And then when we execute this, it is going to return the tokens. And then this code node is then going to decrypt those tokens. Now, I have saved the token key as an environment variable. I'm using a self-hosted instance of n8n. So within my env file, I have saved the token. And here we are going to use that token to then decrypt the credentials. So if I show you what that looks like. So we've run this, it's returned an array of accounts, and at the other end, we then have our access token, user ID, provider, and tenant ID. Don't worry, this would have expired by the time this video comes out, so I'm not exposing anything there. But we can see our user ID, you can see that we actually have SharePoint credentials, and you can see that we have different tenant IDs and different user IDs there as well. Okay, and then this is then going to be returned into our main workflow. So if we come back to our Teams transcription workflow, first thing I'm going to do is I'm going to execute a sub workflow. And I'm going to execute the get token workflow. Just do that now. So we've got some data to work with. Now I only want, well actually we're going to use both SharePoint and Graph tokens for this workflow. But for this first step, we only want Microsoft Graph tokens, not SharePoint tokens. So I've added a filter here, which is going to filter anything that's not provided Microsoft. So it's going to filter out the SharePoint tokens effectively. I'm going to connect this to the Get Profile node. Now what I have done here is I have removed the previous authentication that was here, and I've added header authentication, so authorization, bearer, and then it's going to take our access token from the previous node. So let's have a look at that. And we can see we've successfully authenticated with the endpoint, and we have output 2 different user accounts, 2 different IDs across 2 different tenants. So the next thing that we're going to do is we need to get the core records. So to get core records, we have to use this endpoint, core records. But this endpoint is only available with application permissions, not delegated positions. So not per user permissions, application permissions only. So instead of using the access token for this, which we don't need, because with application permissions, you can return user-wide records across your entire tenant. However, the authorization that we use is per tenant. So this credential that I have set up here is for 1 tenant. So what I need to do is I need to call this endpoint twice with 2 different credentials to get the core records for each tenant, because I'm using a multi-tenant setup. Most organizations, you're only going to need 1, but I have a development tenant and a production tenant, so I want to get information from both. So to do that, let's have a look at the Auth2 API that's set up. It's set to client credentials. We have a login URL with our tenant ID, and then we obviously have our client ID and our client secrets down here as well. So all we really need to do is change the client ID, okay, and then the tenant ID to get information from the secondary tenant. So I'm going to call this twice. I'm going to create new credentials. I'm just going to copy and paste the details over. So client credentials, the token URL, let's just, I'm just going to open this in a new tab, and then we're going to copy everything across. So let's look at these ones. I'm going to grab this. I'm going to change this ID based on what we have in our application. So I want this tenant ID, place that here. Client ID, so our Azure app registration here. Come to overview, see our client ID. And I have a client secret saved, protected in a password manager. For our scopes, now because we're using application permissions, whatever scopes are attached to the Azure app registration. So look at API permissions, you can see application here for core events and applications here for core records. But we only actually need core records for this one, but nevertheless. Okay, and I'm going to just name this. Okay, so that is our production tenant. Save this. Now when I run this, we should get core records for both tenants. And I have changed the date time value here so it goes a bit further back in the past, so we can make sure that we capture some core data. And there we go, we now have core records from 2 separate tenants. So the next thing I want to do, move this out the way a bit, let me tidy up a little bit. I'll move this down here, grab all of this, move it out a bit. Now what I want to do is I want to merge these together, so let's use a merge node. It means I'm going to have to change some things downstream. So there we go. And pen should work for this, let's just check. So we've popped the merge node in, we've used append, which will just give us everything that we need from both outputs. And then we're going into our code node here. So let's just check to see if there's anything that we need to do. Okay, so we've updated this JavaScript so that it apps all the IDs on the get profile. HTTP request. I've tested this and run it, and we can now see that we've output 9 items. So it's found 9 forms. So next, we need to make sure that there's a join URL. Let's do that. And it's found 1 item of the 9 with a join URL. So I need to do a little bit more analysis here, because at the moment we are only returning meetings from one tenant which we were testing in, which is the dev tenant. So let's do a bit of investigation to make sure that we're actually getting data from both tenants. Well, we know we're getting data from both tenants, but let's just analyze and see what's going on here. So we can see on this side, the first item contains everything from tenant 1, whereas the second item contains everything from tenant 2. So we probably need to update this JavaScript a bit more so that it goes through all the items. As we can see here, we are only accessing the data in position 1. So let's update this. So we're going to update this code. So we're now not just looking at the first item. Let's see what we get. 24, that's promising. We've got more items come out there. And let's just do our filter for the join URL. And there we go. And we've now got 8 meetings that have taken place, which seems right. Okay. Now we're going to get the details, each of these meetings. Let's do that. We've got 8 items. And it looks like we've got some errors, of course. So again, we need to make sure that we are using the correct authorization, because right now it's only returning details for one user. So we need to update this to return details for both users that we're trying to pass through from each tenant. Okay, so to do that, from our sub-workflow execution, we do have a user ID, and we also have user IDs for core records. So we should be able to append the access token using this code node so that each item has the correct access token based on the user ID. So I'm going to update this JavaScript to do that. Okay, so looking at the values here, the input values from the get token sub workflow, come back over to that workflow. If we have a look at the outputs, what we can actually see is we have a user ID here, and we have an account provider ID. Now, we don't actually want this user ID. What we want is the account provider ID. We just want this first part of it to match what's coming from the get profile row here. Because if we look at the ID, you see that ID is a match for this part. So we're going to update this JavaScript within the sub workflow, which I've just done. And I'll test this. Now hopefully our user ID should be correct. So I'm going to save that. And if we come back over to our main workflow here, let's just execute again. And we've updated this JavaScript. Now we should have 2 extra items at the end. So we have our Microsoft token, and we also have our SharePoint token because we're going to use that a bit later as well. So we've got everything that we need to continue. So then we are going to filter. And then we're going to get our online meeting details. So for this, we want to change this back to none. We want to send a header. It's going to be the authorization item. We want our Microsoft token. And we should be able to get details for each meeting without any errors this time. And there we go, we now have meeting details for both users across 2 different tenants, ready to continue with the rest of the workflow. Okay, so now we've identified that these meetings did indeed take place online. Let's continue with the rest of the workflow. I want to test each step to make sure that everything works as expected. And I'm going to make sure there's no duplicates here. If there were, so that we've reduced them down. Interesting. Let's just see what the output of that is. Nothing missing there from memory. Interested to know why it's reduced so much though, so I'm going to do some analysis here and just make sure this is nice and clean and tidy. So we've identified that there is some duplicates coming out of this code node, which you can tell by the IDs being the same. So I'm just going to have a look at this JavaScript and tidy it up a bit. Okay, so what's actually happening is there's 2 items coming out of the get profile node here. What we're actually doing is we're hitting each of these endpoints twice, which is causing duplications over here, which we don't want. So we want to make sure that we're limiting what we're doing here. So I think we need to just tidy this up a little bit. And when we set the time range, I'm also going to use some values here to tidy up. So we could potentially use the user ID for that. So I'm going to set user ID here. And then I'm going to use an if. A bit more than that because we're going to 2 different tenants. So try using a tenant. So I'm going to add the tenant ID here, and we're going to use the tenant ID, split these to route these to the right HTTP request. So if nodes, if nodes here. So true, have a look. Grab the ID, see what order they're coming out in. So if the test this, so we're going to say if the tenant ID is equal to this, and we should get 1 true, 1 false. We'll route the true one here, route the false one here. Okay. And just give this another test. See if it removes our duplicates issue. There we go, that looks much better. 4 items. And then we're going to execute our remove duplicate node. And we've got 4 items there. And we're only removing duplicates that are present in the current run, not across previous executions. And that is because, as I explained in the template video, we are going to do some checking here around processing. Okay. So let's check our combine IDs. Check there's no duplicates here. There's no. Check the data looks good. It does. And we can hit our check if process node. One of these meetings has been processed previously outside of this video. So keep our matches. Great. And let's see what we've got here. Now, everything else is pretty good. Let's unpin this. And I'm going to execute this node over here. It's telling us that all three of these were scheduled by third-party tools, which I actually don't think is correct. So I'm going to do some analysis and figure out what's going on here. So I'm noticing in the output here we have the same user ID, which is incorrect. So something else around here needs to be changed. Okay, so after some further analysis, I can see within our Postgres note we have got this set to first. So previously this was only supposed to work with one user. Now it needs to work with multiple users, so we need to update this to do that. So I think what we'll do, this combine IDs node here, we'll have an organizer object which has the user ID, which is what we're looking for. So as opposed to using our get profile here, we will access the, we'll change this effectively. We're going to switch this over to JSON, and I'm going to say user ID is here. We're going to get rid of that, and we're going to use user ID here, and looking for the name, the organizer, effectively. So the name of the organizer isn't actually available from these outputs, so we're going to have to map it from somewhere else. So coming back to our workflow and looking at the core records, we can actually see that we have the display name of whoever the core record belongs to. So that would be whoever organized the meeting. So all we need to do is map that to our outputs within this code node, and that should give us an available key to map over here. So let me make some more changes to this JavaScript. Okay, so I've made a slight change to this JavaScript, so we include the display name. Let's just have a look at the output. And there we go, we have got the organizer, organizer display name in the output. Great. So just run the whole thing again up to this point. Okay, so slight error there on my part. The output of the combine IDs, because we are including all other fields, is actually coming from the online meetings request, not from this code node. So we need to join the data from the code node and the online meeting details HTTP request. So we should be able to open a merge node. So let me analyze that and I'll come back to you. So let's have a look to see what's common. We're using join URL to get the meeting. There's the join URL. Yes, we have that here in the output. So let's see if we can merge in here. And we'll take we'll do that. Then we will say combine, and we'll say fields to match on. So from input 1, let's think about this. We've got 4 items there, a bunch of different items there. Probably want to split them out first before we do this. So get rid of that, get rid of that. Let's move this over here. Pop this here. And we're going to use our join URL. And just have a look. Got 12 items here. So let's do another split out. Apologies if I'm going a bit too fast. Do feel free to slow down the video. We're going to split out. We don't need to because they are not in an array. So let's just map this straight over here. Input 1, input 2. We've got our join URL. Not nested anywhere. So let's see if that works. Not quite. DY. Okay, so these have slightly different names. We've got join URL, and then we've got join web URL. So we're going to say these have got different names. Input 1 is join URL, and then input 2 is join web URL. Let's see. There we go. Then we've extended the outputs. See if we now have our display name, which we do. Great. We'll move this over here. Not changed the structure of the data, we just extended it. So everything else should be good. Let's just check over here. And we just need to make some changes here. We just need to make sure that this merge node is doing what we want. Merge both inputs together. We are keeping matches. And for clash handling, I'm going to say let's prefer input 1. And just run this again. Okay, that's okay, I think. Okay, so I've came back over to our merge node here. And I've switched this from a deep merge to a shallow merge. And that means that we can retain the structure of the data, which means that we no longer have an error with the participants. So I'm going to switch this back to as it was previously. For consistency, let's grab the organizer ID, just a principal name. This is the. So we may have just wasted a few minutes there by getting the display name because it's actually the user email we're looking for. But nevertheless, we needed to split everything out. Let's go into participants, organizer, and let's grab the user email. There's ever going to be one organizer for the meeting. Okay. Right. Let's run this again. Got our 3 items. And now let's see what we have. Hopefully we should have different user IDs. Quite. And that is because we are not. These roles already exist in the database, so I'm probably going to have to clear them out. Let's execute this step again. Still got our 3 items. I'm just going to check what the outputs are from the database. Yeah, now the user's changed. This is to be expected because I would expect this meeting to come from the production tenant. Okay, now let's run our merge node over here. Now let's see what's happening with our, of course we need to, okay, so now that we have got the correct items coming out of the merge node, we need to update the get transcript data node so that we are using the correct tokens effectively. So same process. So we have our token data here. Now I'm expecting n8n to possibly get confused, not knowing which item to use if I map it directly over here. But let's give it a shot and see. Okay, so the authentication tokens have expired. So let's run the whole thing up until this point so that we can get new tokens. So within our HTTP request for get transcription data, we've switched this from the previous permissions that we have within n8n, and we are now sending the authorization access token, authorization header with the access token from our combined nodes, which is actually working fine, which is good. So then we can see we are outputting two. So we found 2 transcriptions there, and we've errored on one. The one must have been scheduled via a third-party tool, which means it can't find transcription. There's no meeting object for meetings that were scheduled with third-party tools. So this is, as I mentioned in the template overview, so we're going to search for that down here. So we know this one's going to work. Need to change these permissions, but here we're going to search for the online meeting. Now, of course, we're going to have to change this to use our, what we're looking at. So this is the graph as well. So absolutely great. Okay, so what I'm noticing is that the date value is wrong here, because this is meant to work and search on the same day that the meeting took place. So actually, the date value here is incorrect because we're taking a new date for the date the workflow was run. So that's no good. So I'm going to have to update this to use the dates that the meeting actually took place. So we can actually get that from our merge nodes over here because we have got the meeting start. So instead of using just new dates, expression, get rid of that and replace it with meeting start. And then we're going to have to just modify the expression. There we go. Now it should find the meeting. Great. So we've now, so even though it's not available via the transcription endpoint, we have now done a search and we've still been able to find the meeting by searching. Essentially what we're doing here is we're searching SharePoint or OneDrive for the video of the meeting. Okay, let's continue. So we need to change all of these to use the correct authentication now. Okay, so this is where we're looking at SharePoint. Now there's a couple of things that need to be dynamic here. We need to make sure that the URL is dynamic, and we obviously need to send the authentication token as well. So let me have a think about that. Okay, so what I have identified is that when we search for the meeting, we actually have the web URL here. So we can use that in our list transcriptions request to, so essentially we want to replace this with the first part of this web URL here. So we're going to need an expression to strip anything after this part. Drag this over here. And I'm going to ask ChatGPT to update this expression to just remove this last part here. So ChatGPT has given me some lovely regex here to extract the bit that we need. I'm using a split out, so that should be absolutely fine. Just then we need to change the authentication. So this time we need the SharePoint token head down to combine IDs, and we will get our SharePoint token from over here. And we'll hope this works. I need to add bearer. And there we go. We now have our temporary download URL for this hidden transcription. This endpoint is quite hard to find, but it is there. Now we have the download URL for the transcription that wasn't available via the transcription endpoint. Oh, and of course, we need to get rid of this. Yeah, you don't actually need authentication to get that because it's a temporary short-lived URL. And now we should be able to run all of this up to our merge node. With 2 items, uniformed, normalized, which is great. The next thing we need to do is update this Microsoft Outlook node, change it to a HTTP request. We can't, unfortunately, the only downside to doing this is that we can't use nodes which require credentials, so we have to use HTTP requests. Not a big deal because we can just import it in Co. So, all good. So I'm going to run this, just dealing with quite a large amount of data. I'm just going to put temporary whilst I'm testing. I'm going to limit this to 1. So all I've done there is I've given this to ChatGPT and told it to give me the equivalent in Co. And there we go. That's all you need to do. And then you can see it's even filled out this, so we can put our access token here. We probably will need to update some of these expressions to match what we had previously. Let's do that. We also probably just want to make a change to what's coming out of this merge node, because we're going to need our token for the HTTP request. Okay, so for these routes, we need our Microsoft token. We've got email send request in the app registration. So or do we? Maybe we don't. We might need to add a mail read, mail send. Yes, we do, mail send. So we're good. Add a token. We'll come back down to our combine IDs. Grab our Microsoft token. Write that. Then over here. Now, obviously, this is going to break our form route up here, but to be honest, it's very unlikely that this is actually going to be used. Much more applicable for personal. I'm going to leave it there though in case I want to use it in the future, but it's probably highly unlikely, so I'm not going to update this one. You could connect it and do that if you wanted, but I'm not for the time being. Okay. Execute this. Make sure that we have our token. Okay, and that gives me the opportunity to execute this again. And then for each of the outputs, we should have an access token. So we are going to move this, replace this here. No, we do not want to create an infinite loop. That would be terrible. And then take this request. No, I just want to do a comparison with what we had here, because we're going to have to update these expressions. Yeah, okay. We're going to want to extend these, include the email. So where can we do that from? User email. Great. We take it from the merge node. And we'll just say user email and execute to this point. Okay. So now we can access the user email from the loop. Save this. Okay, so our HTTP request here failed. So we formatted something incorrectly. Let's have a look and see what that could possibly be. My guess would be the HTML that's going on here. Yeah, so we're going to need to probably stringify this. It's a JSON string. See if that fixes it. Watching it's running the analysis again, I should have pinned this. So, okay, it's now getting a slightly different error because, of course, I haven't mapped the token. So let's do that. Token mapped, and this time I'm going to pin the AI node and execute again. Okay. This time I sent the email. Great. But we can see our saved data didn't work. Have a look at my email inbox. And I can indeed see the email. Let's figure out what's going on with our Postgres node. So we need the user ID. It's due to some database restrictions. So let me sort that out. I need to get the user ID from somewhere. Again, I want it to come in the loop so it's nice and clean. So I'm going to map the user ID from somewhere else in the same way that we have done previously. We've got the user ID here. So I should do exactly the same thing. Okay, so I have now mapped the user ID to both of our set nodes. We'll just run it again. Exactly the same as before. Have our user ID, go into the loop. Great. Let's look at our saved data. We'll take an expression. We'll go to the loop and we'll grab the user ID. Test this. we're good to go. So we have now revamped this workflow for it to work with multiple users. As long as the user signs in via our token manager or any other solution that you want to use as a token manager, we can get those tokens. We now have a multi-user workflow that can be used across the organization. And that's a wrap. We've gone from capturing Microsoft Teams transcriptions all the way to detailed participant-aware summaries, drafting follow-up emails, pushing everything out to a knowledge base, and most importantly, you've seen how to take what's normally a single user automation and scale it to work securely across an entire organization using our MS Auto Auth 365 platform. If you found this useful, check out the links in the description. The single user version is on the n8n template marketplace. The multi-user version and the authentication app is available via our blog. And of course, more examples of how we're using AI and automation to drive real impact inside business. If you have any questions or want to see how this could be adapted for your own use case, feel free to get in touch. We do have a community over on our blog. Feel free to check that out and join. I am active in there. I look forward to hearing from you. So thanks for watching and see you in the next one.